Hello friends, welcome to Expert Guidance. Today we will be covering a very important topic of your GCSE Maths, which is Surds. Now most of the students think it's a complicated topic, it is difficult to understand, but it is not. It's very easy, and today I'll take you step by step from the step 1 till the end how to study this topic. We'll be covering each and every concept. Along with it, we'll be doing the practice questions, which you can practice along. So in this video, we'll be covering how do you write surds in simple form, how do we add surds, how do we subtract surds, how do we multiply surds, how do we divide surds, how do we expand the brackets with surds, how do we rationalize surds, and we'll also do surds word problems. Okay, so let's begin. Now, what are surds? Now, you must have seen some numbers written as root signs like root 2, root 3, root 5, cube root, fourth root of 7. Now, all these words, all these letters, when you put it into your calculator, you get a very big number with a lot of decimal places, and they have infinite number of non-recurring decimals. So we cannot write them exactly. So the best way to write them is to keep them in the root form. And these are known as surds. So surds are something which is denoted as a root sign, which are irrational numbers. And best way to write their exact value is to leave them as a surd as it is. Okay, so now let's see how do you write the surds in a simple form. Now, to understand this, how to write a surd in a simple form, it's important that you go over my previous videos where I have explained to you how to write any number in the form of its prime factor. So the first step is to write any number given to you in the form of its prime factor. After writing them as prime factor, find how many pairs they are and write those pairs outside the surd sign and then simplify. Now let me explain this with an example. Let's suppose you are given a number called square root 48 and you need to write it into a simple form. Now if you remember from my previous video, how do you write a prime factor of a given number? You take 48 divided by 2, it becomes 2 times 24, where 2 is a prime factor, you circle it. Now you take 24, break it into 2 times 12, and circle 2 as it is a prime factor. 12 is broken down into 2 times 6, circle 2 as a prime factor, and break 6, and you get 2 and 3. And you keep on doing until you get all the prime factors. Now 48 can be written as 2 times 2 times 2 times 2 times 3. So that's what we have done here. We have written 2 times 2 times 2 times 2 times 3. Now we'll find the pair. This is one pair of 2, so we have written as a single 2 outside. This is another pair of 2. We have written as a single 2 outside. We are left with just root 3. So the simple form of square root 48 is 4 root 3. Again, the step is write the number as prime factors, find out the pairs, write the pair outside the surd sign. That's it. Now let's try this number. This is square root 27. Now let's try to make the prime factors of 27. 27 cannot be divided by 2. So let's divide by 3. So it is 3 times 9, which is 27. Now 3 is a prime factor. We'll circle 3. 9 can be further divided into 3 and 3, which is a prime factor. Now we have got all the prime factors, so we'll stop here. So now square root 27 can be written as 3 times 3 times 3. Now how many pairs are there here? Just one pair. So we'll strike these two numbers, write them as a single 3 outside, and we are left with square root 3. So the simple form of this is 9 square root 3. Okay, so I hope this is clear to you. You can try more questions on them, but as we move along, we have to use this concept. Okay, so this is how you simplify surds. Now let's see how do you add the surds. Now for adding and subtracting, you can only add and subtract if the surds value is the same. So for that, first you write the surd in the simple form. If the surds digit is same, then you add the whole number and keep the surd unchanged. For example, here root 5 and root 5, these surds are same. So you'll write them as root 5 and you just add the whole numbers. So this is 2 and this has nothing written on it, it means it's 1. So 2 add 1 is 3. So that becomes 3 root 5. Okay, let's try another one. Root 7, surd is same. 5 add 1, 6. It will be 6 root 6. 6 root 7. Now let's try this question. Here 5 root 2 is already in the simple form, so we will not do anything with it. But 3 root 6 is also in the simple form. 3 root 2 is in the simple form. Now, these two numbers have the same surd, so only these two can be added. So 5 add 3 is 8, so that becomes 8 root 2, and 3 root 6 we will write as it is. Okay, so always remember to add the surds should have the same values, and you add the whole numbers. Okay, now let's look at this question. Here, square root 20 and square root 45 are not into their simple form. So, okay, now let us look at another example, which is 7 root 20 plus 4 root 45. Now here root 20 and root 45 are not into this simple form. So now let's first simplify the surds. Now if you remember from the prime factor video, 20 can be written as 2 times 10, where 2 is a prime factor. 2 can be written as 2 times 5. Right? So our root 20 is written as 2 times 2 times 5. 2 is, these are in pairs, so we'll write them outside the surd sign, and this will become 14 root 5. Okay, so 7 root 20 can be written as 14 root 5. Now let's do 4 root 45. How do we write 45? It will be divided by 3, 3 times 15. And then 15 can be written as 3 times 5. So it's 4 square root 3 times 3 times 5. This is a pair. We'll write that as a single number. So 4 times 3 is 12 root 5. Now our surds are same. We can just add the whole numbers and the answer would be 26 root 5. Okay, so I hope how do you add the surds is crystal clear to you. You just need to make sure, write the surds in simple form. Make sure the surds are same and then add the whole numbers. The same thing we'll do for subtraction. So write the surds in simple form. If the surds digit is same, then add the whole numbers if it is addition, or subtract the whole numbers if it is subtraction. Okay, now let's see. It's 3 root 7 minus root 7. The surds is same, which is root 7. So we can just do 3 minus 1, which is 2, and the answer would be 2 root 7. Right? In this question, root 6 is different, but root 2 are same. So we can do 5 minus 3, which is 2 root 2 plus 3 root 6. Now for this question, square root 12 and square root 27, they are not into their simple form. So first write into their simple form. So I'll start with 12. How we can write 12 in the simple form? It will be written as 2 times 6, and then 6 will be written as 2 times 3. So the prime factors of 12 are 2 times 2 times 3, and for square root 27 we just wrote into the simple form here, which can be written as 3 times 3 times 3. So square root 27 is 3 times 3 times 3, and a square root sign. We take this pair outside, so it becomes 2 root 3 minus, this pair goes outside, 3 root 3. So 2, as the surds are same, we can do 2 minus 3, which is minus root 3. Okay, so I hope this is clear to you. Now let's do the same thing here. Root 12 is written as 2 root 3. So 2 times 2 root 3 plus 3 root 5 and square root 20. So we just wrote square root 20 in the previous question. We made the roots for square root 20. Yep, so square root 20 is 2 root 5. So we can write it as 2 root 5. Now let us put that into simple form. So that is 4 root 3 plus 3 root 5 minus 2 root 5. So 4 root 3 stays here, and 3 root 5 minus 2 root 5 is plus root 5. Okay, so I hope this is clear to you. So I hope how to add and subtract the surds is clear to you. Now let us move on to the multiplication of surds. Now in order to multiply the surds, it is more simpler than adding and subtracting. You just multiply the whole numbers together, multiply the surds together, and solve and see if you can further simplify that. For example, here the whole numbers are 1 and 1. 1 times 1 is 1. 8 times 8 is 64. So that becomes square root 64, and you know square root 64 is 8. Let's do another question. You can only times the surds and the numbers. So 5 can only be times by 4, which is 20, and 2 times 6 is 12. Okay, now we can write 12 in the simple form. 12 in the simple form can be written as 2 times 4 times 3. This 2 can go outside, so that becomes 40 root 3. Okay, now let's do this question. 3 times 4 is 12. Square root 2 times square root 2 is square root 4, and square root 4 is 2. So the answer would be 24. Let's try this question. 2 times 3 is 6. 32 times 2 is 64, and 64 can be written as 8 times 8. The pair we can strike it out. So it's 8 times 6, which is 48. Okay, so I hope this multiplication of surds is clear to you. Now let's move on to dividing surds. Now in order to divide the surds, do the same thing. Divide the whole numbers together, divide the surds together, and simplify and solve. For example, here you have square root 75 divided by square root 3. So we can write it together, 75 divided by 3. So 3 times 1 is 1. So you get square root 25, which can be written as 5. Let's try this another question. This is 15 root 6 divided by 5 root 3. We will divide the whole numbers together. So which is 15 over 5 over 6 over 3. 5 times 1 is 5, 3, 2. So the answer would be 3 root 2. Okay, so I hope this is clear to you. For this square root 12 and square root 121, let's first try to write them into simple form. So square root 12 can be written as, we just saw in the previous example, it can be written as 2 root 3. And square root 121 can be written as 11. So the answer is 2 root 3 over 11. Okay, so I hope you are clear with adding, subtracting, dividing, and multiplying, because we'll be using next in expanding the brackets and rationalizing the surds. Now let's see how do you expand the bracket. You must have done 2 brackets in algebra. So we'll do that in surds. Now when you have anything like that, you will multiply this one number with all the numbers of the second bracket. And then you will multiply the second number with all the numbers of the second bracket. And then you simplify. All right, now let's see. So first we'll start with 5 times 5, which is 25. Then 5 times minus root 2 gives minus 5 root 2. Then root 2 times 5 gives plus 5 root 2. And root 2 times root 2 is minus 2. It is minus root 4, which could be minus 2. Now this 5 root 2 and 5 root 2 get cancelled because they are the opposite sign. You have 25 minus 2, which is 23. Okay, so I hope this is clear to you. Now you can pause this video, have a go at this question. In this question, you'll multiply root 5 with all the numbers inside the bracket. So root 5 times 3 root 5. Remember the multiplication rule. You can multiply the whole numbers together and the roots together. So 3 times 1 is 3. Square root 5 times square root 5 is square root 25. 2 times 1 is 2. 5 times 20 is square root 100. Now square root 25 is 5 times 5, which means it is 5. So that is 15 times square root 100 is 10. So we'll get 15 plus 20. So the answer is 35. Okay, so I hope this is clear to you. Now have a go at this last question. Again, the same rule. We'll multiply 2 with all the numbers of the second bracket. And then we'll multiply 3 root 5 with all the numbers of the next bracket. So 2 times 3 is 6. 2 times 2 root 5 is 4 root 5. 3 root 5 times 3 is 9 root 5. And 3 root 5 times 2 root 5 is 6 times 5, which is 30. So 30 add 6 is 36, and 9 add 4 is 13 root 5. Okay, so I hope this is clear to you. These kinds of questions can come in the exam because here they're testing all your surds concept. They're testing how you put the surds in simple form, how do you add them, subtract them, multiply them. Okay, now let's come to rationalizing surds. Now in rationalizing surd, what is the meaning of rationalizing surds? Rationalizing surd means that you get rid of the surd in the denominator. So you convert the denominator into a whole number. Now how you do that, if the denominator is a single surd like this, then you multiply and divide by the denominator. If the denominator is an expression like 1 plus root 2, 2 plus root 2, then you multiply and divide by the denominator with the opposite sign. Okay, let's take an example. This is 1 root 5 since it's a single surd. So we will multiply and divide by the same surd. So we'll do root 5 times root 5. So 1 times root 5 is root 5 and root 5 times root 5 is 5. Okay, so now you can see in our answer, we have got rid of the surds in the denominator and we have 5 as a number. Let's do another example. This is 1 plus root 2. In this case, we will multiply and divide by the denominator but with the opposite sign. Now, what is our expression? 5 times 1 minus root 2 and then 1 plus root 2 multiply by 1 minus root 2. Right? Now let's open the bracket. This will become 5 minus 5 root 2. And when you expand this bracket, you will get the answer as 1 minus 2, which is minus 1. So your answer would be 5 minus 5 root 2 over minus 1, which can be written as 5 root 2 minus 5 over 1. So you can see in this example as well, we have got rid of the surds in the denominator. Let's try another question. Here, this is 6 times 4 minus root 3. So we will multiply it by 4 plus root 3, which is the opposite sign. So now let's multiply. We have 6 multiplied by 4 plus root 3. And at the bottom, we have 4 minus root 3 and 4 plus root 3. The bottom denominator, you will expand by doing this. So 6 times 4 is 24 plus 6 root 3. And at the bottom, you will get 16 minus 3. So when you expand this bracket, 4 root 3 and 4 root 3 get cancelled. So you'll just get left with 16 minus 3. Now 16 minus 3 is 13. And at the top, you have 24 plus 6 root 3, which will be your answer. Okay, so I hope this is clear to you. Now let's have a go at this last question, which is 3 over 2 plus root 2. Okay, so this is 3 over 2 plus root 2. What will multiply it? Yes, you're right. It's 2 minus root 2. That is the same denominator, but with the opposite sign. So we have 3 multiplied by 2 minus root 2. And at the bottom, we have 2 plus root 2 multiplied by 2 minus root 2. And let's do this. So we'll have 6 minus 3 root 2. And at the bottom, we'll have 4 minus 2, which will give us 2. So 6 minus 3 root 2 over 2 is our answer. Okay, so I hope this concept of rationalizing is clear to you. It is an important concept. Make sure you have understood it well. Now let's see what are some application of word problems that can be asked in the exam. So you have been given this rectangle and you'll be asked to find the perimeter. Now how do you find the perimeter? You add up all the sides. So this is 2 plus root 3. This is 2 plus root 3. And opposite sides of the rectangle are equal. This will be root 3. Now let's do the addition. So it is 2 plus root 3 plus 2 plus root 3 plus root 3 plus root 3. Now what we'll do, we'll add the whole numbers together and the surds. So 2 and 2 is 4. And how many root 3s we have? 1, 2, 3, 4. So this will be 4 plus 4 root 3. Okay, so I hope this is clear to you. Now look at this question. This question looks a little complicated, but trust me, it's very easy. You have been given one square. Inside it, there's another square, and inside it, there's a third square. And you need to find the area of the shaded region. Now here we'll use a little bit of Pythagoras because we know all these angles, they add up to 90 degrees. These angles are 90 degrees. So this is 90, this is 90, this is 90, this is 90. And one thing we know, this is given to you in the question, that these are the midpoints. Now look at this question. If this is 4 centimeter, then this side is 2, this side is 2, this side is 2. Okay, now concentrate on this triangle. This is a right angle triangle. If you have this side is 2, this side is 2, you can find the hypotenuse by using a Pythagoras theorem. So the Pythagoras theorem says that the side HFH will be equal to the sum of squares of these sides, square root. So 2 squared plus 2 squared, square root. So that gives us 4 plus 4, 8, square root 8. So it means this diagonal will be square root 8. Now we know J is the midpoint, so this FJ will be square root 8 divided by 2. Right? Now let's write this surd into a simple form. Square root A can be written as 2 root 2 divided by 2, which means our value of FJ is root 2. So this is root 2, this is root 2. Now, you know this is another right angle triangle where FJ and FH are square root 2. Now, if they are square root 2, we can find the hypotenuse HJ by using the formula square root 2 squared plus square root 2 squared. Square root will give us HJ. Now, square root 2 squared is 2 plus 2 square root, which is 4 square root 2. So it means we have got the side HJ to be 2. So all these sides add up to 2. So what will be the area of the shaded region? It's side times side. So shaded region area will come to be 4. Okay, so these are the kinds of applied questions that can be asked in this question. So I hope that is clear to you. All right, so this is all that you need to know in Surds. So as always, what's our next step? You need to check the specification, make sure you are able to answer all the questions of this topic, and then you need to do exam questions of this. The link to the exam questions are given in the description box below. So we hope you like this video. If you like it, then please do subscribe to my channel and do share, like, and comment this video. And while studying, you have any doubts, then you can join my free Facebook group, which is by the name Get A Stars in GCSEs and A-Level Science and Maths by Mahima Laroya. And you can also come to my website where you have 24/7 chat support where you can put all your queries and get instant replies. So I'll see you next in my next video. Till then, happy revising.